In this video, we're going to use vector E and F instead of A and B to do our calculation as an example. They have magnitude 5 and 3 respectively. So the first question asks us to add vector E and F into a new vector G using parallel transport. So using parallel transport means that we want to move one of the vector parallelly, meaning we should keep the direction and magnitude unchanged. So parallelly until the tail of this vector touches the head of the other vector. So now we can draw a new vector starting from the tail of F to the head of E. This will be our new vector G. So now to get the angle of G with respect to X, which will tell us the direction of G and the magnitude of G, we need to use the law of cosine and law of sines. Let's look at this diagram carefully. We know that vector E will make a 60-degree angle with the X axis. So this angle over here will be 60 degree, which means that this angle here will also be 60 degree. Now, because this angle over here is 45 degree, and the sum of the three angles inside a triangle should add up to 180 degree. Therefore, we can get that the angle over here will be 75 degree. And therefore, we are looking at this triangle with a 75 degree over here, and the side length of the two sides, which is the magnitude of E and F, were given by the problem statement. So we can use the law of cosine to figure out the magnitude of G. Let me write the magnitude of G as the absolute value of G vector. The magnitude of this side of this triangle will equal to the let's say the square of this side of this triangle will equal to the sum of the square minus 2 times the side length times the cosine value of the angle they make. This is the law of cosine. Now we can plug in the number. Vector E has the length of 5, F has the length of 3, and cosine 75 degree is approximately 0.259. So we can add the numbers together. We need to multiply cosine times 2 times 3 times 5. This will give us 7.76. So 25 plus 9 minus 7.76. This is approximately 26.24. Let's keep it to 26.2. Now we can get G by taking the square root of this number. So the square root of 26.2 is 5.12. So now we get the magnitude of G using the law of cosine. Let's move this away. So with the magnitude of G, we can use the law of sine to get the angle over here, because the ratio between the side lengths of a triangle is related to the sine value of the corresponding angle. Now we can use the ratio between G and E to get the ratio between the sine value of these two angles, and then we can solve for theta. So the ratio between G and E will equal to the ratio of the corresponding angle. So we can solve for sine theta, which is 5 divided by 5.12 times the sine value of 75 degree. Let's press the calculator and see that the answer is about 0.943. So the angle over here will be about 70.6 degree. Let's keep it as about 71 degree. So we know that this angle over here is 71 degree. Therefore, the angle it made with the x-axis will be 26. This is how we get the direction and the magnitude of G by laws of cosine and laws of sine. Now, question 3 wants us to find the component of E and F. To do that, we can use the drawing over here. The x component of E means that when we decompose this vector E into a vector purely in the x direction and another vector purely in the y direction, and we adjust their length such that they add up to vector E here. So we see that there's a horizontal arrow and a vertical arrow. The horizontal one in the x direction will be the x component of E, and the one in y direction will be the y component of E. So we see that the length of the x component of E will be the length of E times the cosine value. So the x component of E will be the magnitude of E times the cosine of 60 degree over here. Likewise, y component will be E and then times the sine value of E of 60 degree. And we can write the vector as the x component times the unit vector in the x component, which we denote by I, and the y component times the y unit vector. We can plug in the numbers to evaluate. It is about 2.5, and this is 4.3. So we can write vector E as 2.5 unit in the x direction plus 4.3 unit in the y direction. Similarly, we can write the vector F as the magnitude times the angle cosine for the x component and sine for the y component. But we need to be careful that vector F is pointing downward in the y direction. So we know that we should have a negative sign here to show that the y component of the F vector is negative in y direction. So we can do the calculation. It is about 2.1, and this one is also going to be 2.1. because sine 45 and cosine 45 is the same. So this is how we get the components of E and F. Now we have their component, we can add E and F together using the components and get the vector G. So to do that, we just write out the vectors in their component form. Vector E is 2.5 in I, 4.3 in J, while vector F is 2.1 in I and minus 2.1 in J. To add vectors together, we just add the components with the corresponding component. So we add the I component of E vector and the I component of F vector. Then we get that the I component of G vector will be 2.5 pi plus 2.1. Like this, the J component will be 4.3 from the E vector minus 2.1 from the F vector. So we get that G vector will have 4.6 unit in I direction and 2.2 in the J direction. We can now check our result with the result we get in question 2 by comparing the magnitude. In question 2, we already found the magnitude of vector G, and we should be able to use the component to find the magnitude, because the component of the vector looks like a right triangle. So if the y component is 2.2 and the x component is 2.6, we can get the length of this arrow using the Pythagoras theorem. So we can sum the square of these two numbers and then take the square root. 2.2 square plus 2.6 square, and then is 4. All right, it should be 4 over here. So the square root of 2.2 square plus 4.6 square will give you 5.09, which is about 5.1. So we see that they do agree with each other. The significant number I use is not that accurate, so we can just keep it up to 5.1. And we can check the angle over here by using the tangent value of this angle. Let's call it phi. The tangent value of phi should be 2.2 divided by 4.6. So we can get this angle by taking the arctangent of this ratio. So let's press some numbers on the calculator, and we get is about 26 degrees, which do indeed agree with what we have here in number 2. So we see our result is consistent with each other. No matter which method you use, they should all give you the same angle and same magnitude. But usually it's easier to just add components instead of doing the law of cosine, law of sines. Now, question 6 wants us to see what will happen if we rotate the x and y axis counterclockwise by 30 degrees. So let's do that. Let me draw the original axis using the dotted line. So originally the x and y axis looks like this. The vertical one is y, horizontal one is x, and we are going to rotate this axis counterclockwise by 30 degrees like this. So our new coordinate will be y prime over here and x prime over here. And the angle it makes with the original x-axis is 30 degrees. When we look at our vector g, we see that it is making an 26-degree angle with the x-axis. So we know that it will look something like this. And it should be 26 over here. So we know that the angle between the new x-axis, which is x prime, will be 4. So if we draw the vector g in our new coordinate, x prime and y prime, it will be positive in the x-axis but negative in the new y-axis, and it will make a 4-degree angle over here. And if you rotate the coordinate, it's not going to change the length of the vector. So the length will still be 5.1 units.